If we want to solve a radical equation, that's an equation that has a root or a radical in it, the key is knowing how to get rid of that radical. So in this example, we have a square root with 2x minus 5 underneath it. We need to get rid of that square root sign so we can get that x out. The way to cancel a square root is to square, and we're allowed to do the same operation to both sides of an equation, so we just square both sides. Now, the square root and the square cancel, and on the left, you're left with 2x minus 5. On the right, you have 3 squared, which we know is 9. We're then going to add 5 to both sides, and we're going to divide both sides by 2. We get our answer, x equals 7. And it's always a good idea to check, so we're going to plug x equals 7 back into the original equation. Under the radical, we get 14 minus 5, which is 9, and the square root of that is 3. So it actually checks out. There are going to be times when you're solving radical equations when your answer doesn't check out, and you actually have to eliminate that as an answer. For now, let's see how this problem would change if instead of a square root, we had a cubed root. Well, the way to get rid of a cubed root is to cube both sides. Now the cube and the cube root cancel, and you're just left with the 2x minus 5. 3 cubed is 27. We're going to add 5 to both sides, and we're going to divide by 2. We get 16 as our answer, and to check that, you plug 16 into the original equation. 2 times 16 is 32, minus 5 is 27, and the cubed root of 27 is 3. Alright, let's try another example. The reason we're doing this problem is so I can point out that your first step should always be to get a square root by itself. That's going to make the squaring process a lot easier, and you'll be able to solve the problem much more quickly. So I'm going to start this problem by subtracting 2 from both sides. Now that this square root is by itself, we can get rid of it by squaring both sides, and the rest should be pretty straightforward. The square root and the square cancel. 2 squared equals 4. I'm going to subtract 1 from both sides and divide both sides by 3. Don't forget to check your answer. It does turn out to work in this example as well. Alright, let's step it up another notch here. We still want to get the square root on one side of the equation by itself, and in this example that means subtracting 2 from both sides. But in this example, when we square both sides of the equation to get rid of our radical, we end up needing to square a binomial on the right side of the equation. Don't forget that that means we need to FOIL or distribute on the right hand side. If we do that, we end up getting x squared minus 4x plus 4 on the right, and on the left the square root and the square cancel, we just get x plus 10. So we're still at a point in the semester where our only hope for solving this equation is to get a 0 on one side. So I'm going to subtract x and subtract 10 from both sides of the equation. Now that we've done that, we can recognize that we can factor the right hand side, and we get ourselves 2 answers. We need to check those answers, so x equals 6 I'm going to plug into the original equation. We get the square root of 16, which is 4 plus 2 equals 6. That one works out just fine. Our other possible answer of x equals negative 1, we plug into the original equation, we get the square root of 9, which is 3, plus 2 equals negative 1. That one does not work. So x equals negative 1 is not a solution to this equation. The only answer is x equals 6. Okay, so in class we're going to solve radical equations that have 2 square roots in them. So that'll be how we step it up one more notch, but we'll save that for class, and I will see you there.